Hi Year 11 and welcome to a series of videos for the topic of polynomials for Advanced and Extension 1 Mathematics. In this first video we're going to look at real polynomials, which is advanced content. Let's start with some definitions. Firstly, a polynomial expression. This is how we write it. P of x is equal to an x to the n plus a n minus 1 x to the n minus 1 plus dot 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 plus a naught. Now, n has to be a positive integer or 0. So these are all polynomial expressions. And you can see that sometimes we use p of x or q of x or even capital P of x. Now, the highest power of x is called the degree. So this polynomial, it has degree n. So let's have a look at these. State the degree of the following polynomials. This one, the highest power is 2. This one, the highest power is actually 0 here because this is 6x to the 0. So this has degree 0. And then this one, the highest power is 7. It has degree 7. Now the term ANXN, so the highest power of x, it's called the leading term, but it's not always first in the list. We can mix all of these up. And A naught, it's actually called the constant term. It's the one without any x. For the polynomial p of x is equal to 4x take away 2x squared take away 5, what is the constant term? So we're looking for the term without an x. It's here, don't forget the negative, so it's negative 5. What is the leading term? It's not this one, it's the highest power of x. It's this one, negative 2x squared. And what is the term in x? So that means the term with just an x. It's this one here, it's 4x. Now the pronumerals an, an minus 1, all the way down to a naught are called coefficients. If the coefficients are all real numbers, then p of x is a real polynomial. If the leading coefficient, so that's the coefficient of the highest power of x, is 1, we say the polynomial is monic. Otherwise, it is non-monic. And you've seen this before when you were factorizing quadratics. So what is the coefficient of x squared in p of x is equal to 4x squared plus 5x take away 5? The term in x squared is 4x squared. The coefficient is 4. Now the following polynomials have names. If the highest power of x is 1, it's linear. If it's 2, it's quadratic. This would be a cubic, a quartic, and a quintic. There are other names for higher powers, but we don't need to know them for this course. If all the coefficients are 0, then p of x is called the zero polynomial. We can add, subtract, multiply, and even divide polynomials, although we're going to cover division of polynomials in the extension course. If we're given p of x is equal to 4x squared take away 9 and q of x is equal to 3x squared plus 2x take away 5, we can find p of x plus q of x. All we do is add them. 4x squared take away 9 plus 3x squared plus 2x take away 5, and it's equal to 7x squared plus 2x take away 14. If we subtract, be careful of this minus because we want to subtract all of this, which means we have to put this in brackets. And simplifying, we get x squared take away 2x take away 4. And finally, multiplication. Both of them have to be in brackets now, and we are going to multiply every term by every other term. So we'll end up with 6 different terms. So we get 12x to the power of 4 plus 8x cubed take away 20x squared. Take away 27x squared. Take away 18x plus 45. And that ends up giving us 12x to the power of 4 plus 8x cubed minus 47x squared. Take away 18x plus 45. A polynomial equation is formed when we put our polynomial equal to a constant, like k. So if p of x is equal to 4x squared take away 9, find x if p of x is equal to 7. So we'll form our equation, 7 equals 4x squared take 9, and we'll solve it. 4x squared is equal to 16. Divide both sides by 4. X squared is equal to 4. X is equal to plus or minus 2. Real numbers that satisfy the equation p of x equals 0 are called roots or zeros of the polynomial. And you've met this before when we were looking at quadratics. Graphically, these are the x-intercepts. For example, find the roots of the quadratic polynomial x squared plus 5x equals 6. We put our polynomial equal to 0, we'll factorise, and we'll use the null factor law to solve. What makes 0 here? Negative 2. What makes 0 here? Negative 3. So the roots are x equals negative 2 and negative 3. There are three main types of roots for p of x is equal to 0. There's a single root where the curve cuts straight through the x-axis. It would look like y is equal to x minus a. There's a double root where the curve comes in, touches the x-axis and turns around. It would look like y is equal to x minus a all squared. And there's a triple root where a curve comes in, touches the x-axis and then keeps going, so it stops momentarily here. And it would look like y is equal to x minus a all cubed. Okay, that's it for this lesson. In our next lesson, we're going to look at graphing polynomials.